Swayam Prabha. Digital India. Educated India.
All along during our discussions in this course on project management, we have been talking about a variety of procedures for project planning, project scheduling, project monitoring and control, and a variety of other computations that are involved. In this entire exercise, obviously it is helpful if suitable computational aids are available. And computers have come to play a very significant role in practical project management. So in today's lecture, we are going to look at how computers help in managing projects, what are the kinds of features that are available in commercially available packages, what kinds of packages are available, and how do we have to choose a particular computer package. There is a plethora of computer packages available today, and therefore one can very easily be overawed by the variety that is available. Nevertheless, the core features that are required of a computer package and the kinds of activities that it performs, these are relatively few and well structured, so we should have a look at some of those features and then try to evaluate the major computer packages that are available. I think before we begin the discussion, it is necessary for us to understand as to why we use computers at all. What are the basic advantages of using computers? And in the context of project management, therefore, let us try to answer this question. And let us try to identify some of the major advantages of using computers. When we talk about advantages of using computers, there are many advantages, but some of the significant ones are, one of the probably the most significant advantage of the use of computers in practical project management is that it permits easy sorting of activities. Now this by itself is a major advantage, because quite often practical projects could run into thousands of activities, and quite often the project manager is interested in knowing a variety of things about these activities. He is probably even this list of which activities are completed and which are not completed at a particular point of time, right? Making this list itself is a gigantic task, and updating this list from time to time is again a very difficult task. So the very fact that we have this sorting capacity in the computer, this makes many management tasks very simple. For instance, we can sort the activities according to their floats. This is a very common sorting which is resorted to. What happens here is that you identify the activities which are critical, those which have zero float, and then the relatively lesser critical activities, and then so on until you find the activities which have the greatest float. This would in fact be equivalent to an ABC classification that you have in materials planning. You can sort out the activities according to their floats, identify the activities which are most critical, and thereby try to arrange your management effort based upon the degree of criticality of the activities. So this kind of sorting out is very easy when you are using computer packages. You can sort out activities on the basis of their early and late start dates. This in fact is very useful because it identifies the timetable for the activities. Which are the activities which are due for January, which are the activities which are due for February, which are the activities that are due for the next 3 months. All these kinds of questions and all these kinds of lists are very easily obtained and can be very easily done on a computer. Another very important classification that management finds handy is sorting of activities by their responsibility codes. Different activities in a project are typically done by different individuals or different agencies, that is, different people are responsible for those activities. For instance, you want to find out which are all the activities which are the responsibility of the manufacturing department, right? So out of 3,500 activities, maybe 569 activities are the responsibility of the manufacturing department. You can print out a list of the activities by responsibility code, and you can let the management know exactly which are the responsibilities of different individuals or different agencies. So this itself helps in conducting the project in an easy and an efficient way. Another sorting that is possible using computers is the sorting of activities by their activity numbers. You can number the activities in any order that you feel like, 1, 2, 3, 4. It could be a topologically ordered list or any other list, and you could refer to those activities by their numbers, and you could also sort out activities by their activity numbers. Now this sorting of activities by whatever means you want to do, in fact why it is useful is that these sorted lists tend to simplify management tasks considerably, and it is because of this simplification that computers have found tremendous use in trying to plan and implement projects, because all these routine management tasks can be handled very effectively when one is trying to use a computer. So sorting of activities and by float or early late starts or responsibility codes or the activity numbers could be very useful to management. Apart from this, another very important use of computers is that they permit easy updation and monitoring, and I think this is perhaps the greatest use of the computer in practical project management. In days when computers were not available, for instance, the project network would be made by a draftsman. It would be a long big piece of paper or cloth, as the case may be, and the entire network would be drawn. It would take maybe weeks for the draftsman to draw that figure showing all the activities and the dependencies and everything, and then maybe the network is then hung in the project manager's office, and that would be used as a tool. But what would happen is that quite often, because of the difficulty of updating that network, actually that network is useful only if you update it. As you keep on getting new information from each review, you have to recalculate your critical path, you have to calculate all these things again. Now if it is manually done, then these kinds of things would become difficult, and therefore for all practical purposes, in the earlier days the project chart once made would be hung, and literally hung, in the project manager's office. But now with computers available, this kind of updation and monitoring is very simple. So this makes basically the critical path methods useful throughout a project's life cycle. So this has been perhaps the most significant single contribution of the computer in popularizing project network techniques, because you can take a printout of the new critical path at any stage and then get revised reports, and it's relatively much easier to keep track of the project with these kinds of methods. So easy updation and monitoring is perhaps a very important use and a very important feature that is available with computers. Another reason or why computers are useful in practical project management is the fact that they facilitate certain kinds of advanced analysis which would become very difficult and tedious if it was done manually, right? And what we mean by these advanced analysis is things like time cost trade-offs. Now if time cost trade-off was to be done manually on a large network of 500 activities, and you were asked to use maybe Fulkerson's algorithm or that heuristic algorithm, obviously it would become a very tedious affair, and especially with the heuristic algorithm there is all the likelihood that you would not be able to pick up the right activities for crashing, and you would not be making the right kinds of decisions for crashing. So with computers available and these algorithms which are there, this kind of thing has now become practical and feasible. All that the manager has to do is to get somebody to input the right kind of data appropriately and then get these kinds of results. A similar thing is true about resource allocation models. Resource allocation is still not very popular in practice. Perhaps most of the time users are content with getting resource aggregation only and getting the resource usage profiles, and most companies refer to that as resource allocation. But with the availability of computer software and computers, this kind of thing has become possible. So it is facilitating these kinds of applications. Cost control is another area which has been popularized to a very large extent by the use of computers. For instance, if you were to use PERT cost and you were to monitor the status of the project at every month, say, once your initial budgeted cost and value curve is available, then all that it requires is that at each review you look at what fraction of the activity has been accomplished. So that would be the only input, and from that you can calculate what is the value of work completed, and similarly you can determine the time and cost overruns from that kind of analysis and keep a physical track of all this. So all kinds of reports pertaining to cost and time overruns would become easy by using this kind of advanced analysis. So these are some of the major advantages that we get when we talk about using a computer. Nevertheless, let's try to find out when is a computer really needed. What are the factors or what are the features in a project that warrant the use of a computer? The first thing is really, what is the size of your network? That's the important thing. So obviously if it's a small network of only 10 or 20 jobs, it may not be worthwhile to think in terms of putting the whole data on a computer. So depending upon the nature of your project, the size of the project, you can easily determine whether a computer is needed. But for practical size projects which involve more than 100 or 150 activities, it is helpful to have a computer which would be able to do all the computations and all the reporting for that particular project. Of course, another very important feature in practice is computer availability. You would tend to use a computer only if it is available. That's important. What can happen is that if for instance you are setting up a project at a backward area site where there is no electricity, nothing of the kind, and your site is yet to begin the developmental work, it might become difficult for you to have a computer infrastructure in such a site, and therefore that would be a reason for you to be able to actually manage all your project management activities either manually or whatever is the way. So this of course is a kind of a prerequisite, you can say, for me. I think another very important factor in determining whether a computer is really needed or not is this fact of the expected frequency of updating. That is, how frequently are you going to make your project reviews, and based on each review, are you really going to update the information pertaining to your network, which would mean that if you update your times based on the experience that you have at a particular review date, your entire schedule, your critical paths, the durations of various activities could change based upon your experience, and you might have to sort of repeat these computations very often. So obviously, if this is expected to be done fairly often, if you want to do it only once a year, then of course it's a separate thing. But maybe if you have to do it weekly or monthly even, then of course this frequency of updating actually favors the use of a computer. The higher the frequency of updating, the greater the advantage that you have for using a computer. Another very important factor which determines whether you really need a computer or not is the kind of desired output listings. What kinds of outputs you would require each time. For instance, if you want to have, if you want to know the schedule, let's say every week, and you want to make sure that this schedule reaches every individual who is responsible for the project. So you would like to have a schedule printed individually for by responsibility code for each individual or agency, and you would like the relevant part of the schedule to be printed out for that individual. So you are really asking for customized reports to be given, and this is possible too. So depending upon what kinds of output listings you really want, it all depends. You can have a computer which can probably do it for you, and of course depending upon the nature of the advanced analysis that you are looking for. By advanced analysis we mean features like time cost trade-offs, resource considerations in projects, cost control, and all these things. I mean anything other than basic scheduling. And of course the network format. By the network format we really mean that is the network going to be in the AOA mode or in the AON mode or in the precedence diagramming mode, because different computer packages give you various options in terms of dealing with different kinds of network formats. So you have these kinds of features. So these are some factors which really determine whether a computer is really needed or not. Now, as I indicated to you that there are a very large number of computer packages and options available for handling practical projects, and therefore what we need is a systematic set of criteria on which we should evaluate these various factors. This is very much a problem of multi-criteria evaluation really. So we should be clear in making any scientific assessment of various computer packages as to what are the features which different packages can have and how different packages can differ on these packages. So we will try to look at some of the comparative features of different software packages and try to see what kind of comparisons or what are the bases on which we can make the comparisons. So when we look at this comparative features of software packages, let's one by one try to identify the attributes which are important. Probably the first attribute which is important is what is the network format that it handles. And the typical options that are available on this front are either the AOA format or the AON format or precedence diagramming. These are typically the three types of formats which are generally available in different types of software packages for handling. The second thing is, the second factor or the second attribute, comparative feature of different software packages, is the manner in which the events in the network are numbered. By and large there are two options for event numbering. One is of course numbering the networks according to the Fulkerson's numbering rule, that is I less than j format. That is, each activity is numbered in such a way that the I, that is the preceding node, is strictly less than the succeeding node in that sense. However, it is not necessary that this be done. Some packages permit random numbering, and of course this gives you much greater flexibility. The greater flexibility comes from the fact that even if you have numbered a network and suppose subsequently you want to insert some new activities with different numbers, either you say one activity is, let us say, 10, 20, and in between you can insert an activity 10, 15, 10, 16 and so on in that sense. But suppose your network is numbered like 10, 11, and in between you want to insert a number of activities, right? So then you cannot conform to the I less than j format without disturbing the numbering of the entire network. And the numbering becomes a big issue because when networks are large, you probably would not like to disturb the numbering scheme of various other activities in the network. So both these features are available in many packages. The third factor on which you can compare various kinds of software packages is the capacity, and typically by capacity we mean the number of arcs that it can handle or the number of activities that it can handle. This capacity typically varies from a few hundred to about 5 lakh activities. Packages can comfortably handle activities within this range, starting from a couple of hundred activities to about 5 lakh activities easily in a as far as the overall project is concerned, right? This is the availability of the capacity. Then we have another feature, the fourth feature which needs to be compared in software packages is what we call calendar dates. You see, whenever we prepare a schedule, we would like that this schedule be translated into working days on the actual calendar that is being followed by the project staff. So there is a provision in most of the packages to adopt what is called a base starting date, and then depending upon the base starting date you can set either a 5-day working week or a 6-day working week or a 7-day working week as the case may be, and you can also feed in provision for holidays. So you can feed in the list of holidays for the year and for the next year and for the next year, and thereby whatever schedule you get, the calendar dating facility in the computer program will basically give you a schedule which will specify the exact dates on which each activity is to be done, right? So it only means translating the schedule that you obtain by a forward pass and a backward pass into the number of working days after allowing for the number of working days and the holidays, etc. in a calendar. So this is a fairly common feature nowadays in most packages which are available. So the capacity to handle calendar dates. Then this is another feature which is slightly interesting. I will try to explain this way. Does your package have a facility to accommodate scheduled dates? What this means is, you know that the total project duration is determined by the length of the critical path anyway, but before you do the analysis you don't know what the duration is, but nevertheless you might want that this project should end by such and such date, which is a scheduled date. So many packages have this option of specifying a scheduled date which is the finish date, and all the activities in the project are then adjusted so that you try to accommodate the completion of the project within the scheduled date. What basically happens is something very simple. It says that this will now have the critical path now may have positive, 0 or negative floats. That's what it means.
if you have a schedule date and you calculate the floats with reference to the schedule date now, if the critical path now, you see normally when we calculate, the critical path has a 0 float. So if it has a positive float, it means that it is very easy to accommodate the project within the schedule date. If it has a negative float, the critical path, it shows that you are short, you will have to do some crashing to accommodate the project within the schedule date. So many packages have this interpretation where they say the critical path can have 0 positive or negative float. So it's just a question of trying to understand how the schedule dates may be accommodated within the framework of the critical path, really speaking. But many packages have this feature, and they can print out, and then once you know that the critical path is negative float, then you try to do something manually. That means you crash some activities and try to get 0 float, right, in that sense. So this is this particular provision that you may have for accommodating the schedule dates in the project. Another feature which is important when you are talking about software packages is the capacity to handle multiple initial and terminal events. I think this is simple in the sense that you know that you can have multiple sources and multiple sinks in a network, but for all purposes of scheduling you can always convert them into a single source, single sink network by the use of dummies and so on. But whether a network, whether a package actually permits this, and why this is important from practice is that quite often managers plan a project in terms of parallel projects. The electrical work has to go on, the civil work has to go on, and these are more or less practical, and there are some 2 connecting nodes at which these parallel networks can be put together. So this is advantageous. This helps merging of parallel projects if we know which are the nodes which this is done. So this could be an interesting feature when one is talking about. The next feature which is important when you are trying to compare software packages is this facility of error detection. And when you are talking about error detection, we are basically talking about the ability to detect loops in the project network, whether this facility is there or not there. You know, loops are not permitted by the network logic in the conventional PERT CPM networks, although loops can be permitted in GERT networks and various other kinds of networks for other reasons. But in a conventional project network there are no loops. So do you have the facility to basically detect these loops and point them out? There might be improper time estimates. Can your computer package detect and point out that you have not selected the appropriate time estimates for various activities? How do you think this could be done? This could be done very simply by either there is a database within the package which would specify that maybe any particular activity has conventionally been within a certain range of, let's say, 3 months to 6 months or something like that, and if it finds that you have keyed in a data like 20 months for that particular activity, it says no, check it, it's something wrong with that. So improper time estimates which are not outside the normal range which you might have specified within the program, or which are available from the experience of past projects which are available in your computer, then does the package have this facility for detecting those improper time estimates and printing out a error signal or something saying that there is something wrong here. Other thing of course is the kinds of outputs that you want to generate, different types of outputs. What are the various kinds of outputs, because quite often different software vary in terms of the kind of output that they want to generate. Now in this context there is what is called a report generator. Most packages have a report generator, I mean, when all the computations are done in any computer program and you want to generate reports, you can have a separate module for report generation, which would actually take the values of the various variables which have been computed and give you the kind of a report that you are interested in generating, right? And this kind of report generator typically has flexibility of reports, because depending upon whether you want a activity listing by responsibility code or activity listing by whatever other code you want, you can get this kind of thing by requesting whatever. But it's mostly like a it would mostly be menu driven thing, right? You can specify that we can give you this and we can give you this and we can give you this. But if you want to get something else, a report generator would probably have the features, and you could, with a little bit of programming effort, generate the report that you want. So quite often the structure of the report generator and how it gives you various kinds of reports could be crucial in choosing a package, because it would determine what kind of flexibility you are going to have in terms of generating various reports. So this is again therefore a feature which is becoming, you know, what is really happening is that basically a lot of computer packages are coming on the scene. They are differing not in terms of their essential structure, but in terms of the frills and the other reports that they generate. Okay. Essentially in terms of, you know, they give you a graphic display of something, and you have various kinds of reports and how the data is presented, and you want a graphical display of all the activities which are getting late, so you know you can have a graph plotted and so on. Those kinds of things are also there. So it really depends upon what kinds of features you're looking for. Another thing which is happening is this, we were talking about reports. So the 10th feature is what kind of graphical output does it give you, the computer package. What is the kind of graphical output? Now typically when you're talking about graphical output, we are typically interested in things like bar charts, which are useful, because this would specify, you know, a typical common output in any package is a Gantt chart of the of the various activities, showing the progress, what is done, where you are, how much is left, and so on. So you can have various kinds of bar charts with different kinds of color code for those activities which are behind time, those activities which are ahead of time, and things like that. Resource requirement distributions are also basically bar charts, isn't it? The plotting of a resource requirement distribution or a resource aggregation profile. What is that? That is also just essentially this kind of a graph which shows you how the resource requirements will vary over time. Network diagram. So these are the three kinds of basically graphical output that we require when we are doing project management. Updating. Updating, as I told you before, is something which is very, very important for purposes of identifying what changes when and what is the revised course of action when you are going to do something else. So updating, what does updating really mean? I mean, in a physical sense, what it means is, if I review my project on a certain date, I have to, based on that, I have to compute what are the remaining durations for the various activities. Right? Activities which have been accomplished, their remaining duration is 0. Activities which are going on, an activity that was originally scheduled to take 10 days, you now estimate that portion of it is done, but it's going to take maybe 6 more days. And activities which have not been touched yet, their durations are as they were before, or maybe if you feel at this stage that they are going to take more or less, you can take a revised estimate. So with these revised estimates, if you just do a modified forward pass to incorporate the review date information, you will have updated information on the critical path and the forecast of the project completion time. Right? This is how you are going to compute the information on the project completion time. So the question is, do packages have this kind of facility for updation? That is another feature of some of these packages. The next feature which is there when you talk about software packages is what is called network condensation. Does the package have this feature of network condensation, which simply means this: condensation of large to small networks. You have a very large network, you want to condense it into a small one, which could probably be fitted somewhere else. So do you have that? It's something like a zooming facility with a camera, right? You can zoom in and zoom out, make something big and something small. Do you have that facility? It could be useful for not only condensation of large to small networks, but it could be useful for integration of two or more condensed networks. You could take a small portion of one network, small portion of another network, put it together and make a new network out of that. That kind of facility do you have? That's called network condensation essentially. And then the expansion of the condensed to a large detailed networks. Because this would allow people to work in modules, in modular. This kind of thing is becoming very, very popular, right? See, it might happen, for instance, if you're talking of the Boeing aircraft company. They have their design office in Seattle. They have many of their products are being manufactured in Australia. Many of their products are being manufactured in other countries. And they're all simultaneously developing the designs, right? So what can happen is a design developed by one particular group immediately transmitted on email to the other in a form of a condensed network is put along with the whole network, so they have a view of the entire network at the head office and vice versa. So this kind of a facility for handling, so this would permit essentially different individuals to work independently and come together whenever they like and get apart whenever they like. So it's like putting the whole thing together, the project together, and then getting their share of the work. So this kind of a facility could be very, very important for that application. The next feature which we talk about in which could be there in project statistical software, right, is ability to do statistical analysis. And typically when they talk about statistical analysis, the common thing that is done is the 3 time estimates of PERT and the normal distribution and the probability estimates for various kinds of project completion times and things. So both these are these features available, the handling 3 time estimates and giving you probability computations. So this is one of the things which is included in statistical analysis. And finally, when you're talking about comparative features of software packages, does the package have what is known as interactive processing? By interactive processing we mean, does it have the ability to check your keyboard entry, and it has some inbuilt checks for errors and things of that kind at various stages. So there could be a wide variety of such interactive processing checks when you are doing this, right? I mean, we are all familiar with the interactive processing. When you are using, for instance, MS Word, if you do something wrong, you get messages that something is wrong or you have done this and so on. And even this wrong spelling, that line which appears when you are typing something into it, is basically something to tell you that there is something wrong, correct it, right? In that sense. So that's an example of interactive processing. So different packages, depending upon their sophistication, could have different degrees and different types of these interactive processing checks. So this is I think this gives you a fair idea of what exactly one could be looking for when you are looking at a package. It's a wide variety of things which could be there when you are trying to look at various packages. Let us now try to look at some of the recent trends in computer software. What are the trends? What is happening? Historically, what has happened and what is the current status in terms of the trends? I think it is perhaps right to say that the trends in software are both. There is both a proliferation and an evolution in software, right? So by this we mean that yes, features have gradually improved, so you get better and better software. So that is evolution in that sense. But for any given thing, previously there were 3 suppliers, now there are 20 suppliers, there are 100 suppliers. So the number of people, the manufacturers of these software has also increased considerably. So this is one thing that ought to be kept in mind. Now what we can do is we can look at what was the basic structure of the earlier packages and what is the basic structure of the current packages. So that will give you an idea of how packages are varying. The earlier packages that were there were simple in terms of, they generally tend to operate with AOA networks or arrow networks. And numbering was always done originally with I less than j, because much simpler and there were no errors, error checks were eliminated and so on. There was generally one output tabulation, simply. They would do a forward pass, backward pass, print out the floats and give you that table, and that's the end of it. And there was typically what was assumed was single starting node and a single ending node. And there was no resource allocation facilities earlier in packages, really speaking. So this was the kind of scenario that used to persist in terms of the kinds of software packages which used to be available earlier. Earlier I mean in the 70s, even up to the 80s, you had these kinds of features which were generally there. What has been happening over the recent thing is that newer versions typically include some modified features. What are these modified features? First thing is that in the scheme of the network itself, there is an increasing trend in most of the commercial available software these days to go in for either an activity on node network representation or a PDM representation. In fact, AON is a special case of PDM, as you know, isn't it? That's what it is. If you specify the 4 types of lags, FS, SS, FS and FF, then this one reduces to just the AON. So there is an increasing trend to use these kinds of network representations rather. We are aware of some of the advantages of AON representations. We have discussed them. You don't need any logical dummies, so there is no problem in drawing the network. The network can always be drawn, and therefore things are much simpler in that sense. And there are other simplifications that come about by using this. So this has been the trend generally. Then another thing that has been happening, as I was saying, that there has been a plethora of graphic reports which appear along with the output. So essentially the same information which you were getting earlier in a table, now you have very nice graphs which show that report, and you have choices of different kinds of reports coming. So much of this has happened primarily because of the fast processing speeds of computers, but then this has also taken place otherwise. Resource allocation is another thing which has been happening. It has been included now mostly, and this has been possible primarily because of the hardware and the software advances which have been taking place. So you have all these things coming in. Yes, and another very important thing that has happened is that vendors and the distribution network has grown for software. Earlier, if you bought a software, you would not know where to take it if you had a problem. You will probably have to go to the single supplier in the United States for that kind of software. But now you have vendors and their distribution network, so that you can refer to them, find out, they will tell you what the updates are and things. Just as a, one of the list of 22 packages with addresses of vendors is listed by this in this textbook by Moder, Phillips and Davis, which was published in 1986. You can refer to this list. 22 packages were available, and the list of vendors and so on is available. At this point of time, of course, the list is much longer, and therefore we haven't made an attempt to compile it. But
Another important thing that is happening in terms of the recent trends is this kind of computer networking for multi-site projects. You see, multi-site projects, most projects are invariably done at different sites. First site, second site, and site K. And because of computer networking, all these things are connected on a computer network. So really speaking, the kind of thing that I was referring to you, that some project planning is being done here, and these projects are either independently developing plans and so on and communicating and then ultimately getting the whole information. This kind of a thing has become very, very popular, and both the software and the availability of the computer network which is connecting all these has made this kind of multi-site project management not only a reality but a big success. Because what can happen is that you can exploit the advantages of the individual sites, cheap labor in one place, more technology available in another place, and so on, and then network and then get this kind of thing available. Let's look at some of the popular available packages which are there these days, all of them. Some of the old ones, earlier ones in India, we had this package called Prism, developed by Tata Consultancy Services. It has been adopted by a large number of people. Many firms have been using it. That's what. Another package was packaged by Proman, developed by M. Dastoor and Company, and many companies were using this in practical project management. A very popular package in project management was the Harvard Project Manager, and earlier it was called the Harvard Total Project Manager. So, but the new version they call it Harvard Project Manager, and this is marketed in India by NIIT. I am listing here only those for whom Indian suppliers are available. So this has been marketed in India by NIIT, and this has been used. But currently what's happening is that MS Project, which is a software developed by Microsoft and which is a sort of a family of the Microsoft family of softwares typically available, you know, on Windows 95 you can get MS Project and use it. This is becoming a very, very useful, user-friendly kind of a software, and is now very popular with many firms. I know at least of Indian Oil, which which had Harvard Project Manager and so many other things in various units, but they are now going for MS Project, big way. Another popularly used software today, you can find about this information on this on the internet, for instance, the Project Scheduler. Currently they are selling this Project Scheduler 7, PS7, right? And this is being marketed by Saitor Consultants. Of course, there's another project which has been a software which has been very popular. It was used to be a massive software among the very expensive class of softwares, Primavera, manufactured or produced by Primavera Systems. But if you look at the various, and of course they are very, I mean, I've listed only some of the popular names in available software for project management. But I would say by and large the MS Project is now I think picking up in a very big way, and perhaps it's because you have, along with it, it has facilities for linking up with MS Word and Excel and Access and all that, the entire family. So you can import files from one to the other very easily. So this is one of the reasons that it's very popular. Trying to answer this question of how you select a software now, we'll quickly look at some of the issues which are involved. Some of the issues are, for instance, what do you want the software to do? You should ask yourself this question, right? So typically it should have bar chart and flow chart capabilities. What types of output reports should it be able to generate? What kind of handling of resource and budget allocations would you like? Should you show working schedules on a calendar? Is the package user friendly? Do the software manufacturer and distributor have a good reputation? So these are some of the questions that you would normally be answering when you are trying to answer this question of what do you want the software to do.
The second thing that you should be doing is you should ensure that the software package at least performs some minimum basic functions. And some of those basic functions have been identified as follows. A software, when you're looking for a software, it should, like when you're buying a car, it should be able to drive you at least 200 miles or whatever it is, and it should be able to go somewhere. So what are those basic functions of a software? It should permit easy development and changes in the project bar charts and flow charts and notes the critical path. You want this to happen. It allows you to see a bar chart or flow chart on the computer screen before printing it, and the charts are easy to follow on the screen. You should be able to do that. Then you should be able to, it should permit you to combine resource and budget information into the project file and to retrieve useful reports on this information. That's what it should be able to do. It should allow you to tie your project plan to a real calendar with allowances for weekends and holidays. Alerts you to overscheduling of individuals or groups as well as to errors in the logic of your dependencies. Which means it should make this check that resource aggregation, you have 5 people. If it asks for 6 people at sheet, it should warn you that you are using more. It should allow you to construct what if scenarios so that you can engage in the contingency planning and update your modifications. It should have a good demonstration file to show you what the program can do. Also has user friendly users manual. That is important. So after you have done these 2 things, depending on what you want, and these are the minimum features, they say that it's a good idea to experiment with the package on a project you have already completed and let the package convince you that it could have helped. So this is like the test ride before you drive the car, right? It's exactly that. So remember that the computer software with its reports and files is only a tool to help you manage the project. The computer will not manage it for you. That is your job. So in that sense, remember that it's a tool, and when you use or buy a software, you should make sure that it performs all these various kinds of functions. So let us summarize what we have tried to do in today's lecture. We have seen that the use of computers in project management leads to easy sorting of project activities, easy updation and monitoring, advanced analysis of time cost trade-offs, resource analysis and cost control. This is being facilitated. Computer packages vary in their features and capabilities tremendously, and we identified some of the features on which these, in fact 14 major features on which we could compare computer packages. There has been a trend towards both proliferation and evolution in the software packages. Networking in the IT revolution can provide useful information sharing and exchange between multi-site projects. A number of commercially available packages are currently available, as we have shown. But from these, we can say that the MS Project is a widely used, user-friendly package for planning and implementing projects from Microsoft. And ultimately, all computer software are tools available to the project manager. This perspective must be kept in mind. They can assist him, but the responsibility of managing the project is entirely his own. So keeping this perspective in mind, we must see that the project software, which is essentially a tool for managing various kinds of projects, must be taken appropriately. Thank you.